Today we're going to be looking at graphing parabolas, or you could say graphing quadratic functions. So generally, quadratic functions are written in the form y equal ax squared plus bx plus c. Now, if the value, the coefficient in front of x squared is greater than 0, then the parabola is going to open up upwards. If the value in front of x squared is negative, then the parabola is going to open downwards. Now, the turning point of the parabola is called the vertex. So this point here would be called the vertex. That's the turning point. And to find the turning point, or the vertex, you could just let x equal to minus b over 2a, okay? So let x equal to minus b over 2a. That's going to give us the x value of the vertex. And then we're going to use substitution back into the original equation to find the y value as well. Okay, so technically it could be written as minus b over 2a f substituting in to get the y value. Okay, so that's how we can get the vertex. Okay, so first I will find the x value, then I would substitute it into the original function or the given function to find the y value. Now, when you find the x value of the vertex, the line x equal to minus b over 2a gives us the axis of symmetry. And the axis of symmetry just divides the parabola into two equal halves. Okay, so let's look at an example. So suppose we're asked to graph y equal to x squared minus 8x plus 12. So here, we want to find the x value for the vertex. So we have x equal to minus b over 2a. So here, a is 1, and b is 8, minus 8. So we'll have minus 8 over 2 times 1. So we have 8 over 2. So the x value is 4. And then to find the y value would equal to 4 squared minus 8 times 4 plus 12. So that gives us 16 minus 32 plus 12. So that should give us negative 4. Okay, now if we want to graph this, we could create a set of points. So creating a set of points, we have our x value, y value. You can put the vertex, since you know the vertex is at the point 4, negative 4, we want this in the middle of our set of points. So you want to take 2 points before and 2 points afterwards. So 3, 2, and 5, 6. So have our vertex sitting in the middle. And now we just say y equal to 2 squared minus 8 times 2 plus 12. And that should give us 0, right? So 4 minus 16 plus 12, that's going to give us 0. So here we have 0. And then y equal to 3 squared minus 8 times 3 plus 12. And that should give us -3. So, and doing the same thing for 5, you get -3. Doing the same thing for 6, you get 0. So now, this is part of the reason why I like to put the vertex in the middle. Because when you put the vertex in the middle, you see that the points around it, the y values come back matching each other, right? You see? So 2 units away from the vertex, you get the same values. 1 unit away from the vertex, you get the same values. Okay, and then we could just go ahead and graph this. I'll just do a quick sketch. Okay, so okay, so substituting in those values, plotting those points. Well, we have 2, 0, we have 6, 0, we have 3, -3, we have 5, -3, and then we have 4, -4. So here it goes. Okay. So our vertex is occurring here. That's our vertex at the point 4, -4. But the line x equal to 4, this line going here, that line x equal to 4 is the axis of symmetry. Okay, so here we saw the A value was positive, so this parabola opens upwards. Now, on the other hand, if we had a negative A value, that parabola would open up downwards. So for example, if we have y equal to minus x squared plus 10x minus 20. So here the x value for the vertex is equal to minus b. So here b would be 10 times 2a. So 2 times -1. So this will give us plus 5. So this is our vertex. We want some x and y values. Put 5 in the middle. So we have 4, 3, and 6 and 7. So putting 5 into that original equation, we had 5 equal to minus 5 squared plus 10x. So that would be 10 times 5 minus 20. So yeah, so the original was minus x squared plus 10x minus 20. So putting in 5, we'd get minus 25 plus 50 minus 20. So that's just equal to plus 5. So we have this point 5, 5. We could do the same thing with the 4, substitute in. So here we get minus 16 plus 40 minus 20. So that should equal to 4. So this is equal to 4. So here is 4. Now for 3. So that's minus 9 plus 30 minus 20, so plus 1. So this is 1. This would be 1, and this would be, this would be 4, and 7 would be 1. So here's our vertex sitting in the middle. And again, you see the y values around it repeats, right? So the y values, 1 unit above and below the vertex, the y values repeat. Okay, and we could do a quick graph of this. Okay, so we could say 1, 2. Okay, so our points here, let me change the color here. So we have 3, 1, 4, 4. We have 5, 5. We have 6, 4. And we have 7, 1. Okay, so this parabola opens downwards. And again, we see that's because here a is a negative value. That value, that coefficient in front of the x squared is negative. Right? So the parabola opens up downwards. Okay. One of the things is that you can have the quadratic equation written this way: y equal to a x minus h squared plus k. So here you don't really have to do any calculations. You can just read the vertex right off. So the vertex would be hk. Okay, so don't be confused with this negative value here. So for example, if we have y equal to x minus 2 squared plus 5, then the vertex would just be 2, 5, okay? Similarly, if we had x equal x plus 5 plus 7, then the vertex would be So even though this is saying plus 5, it's really, think of this as minus 5. So the h value is minus 5. So the vertex would be minus 5, 7, right? Okay. Okay, that's it for now. Thank you for watching.